Hi, I'm Eric, and in this video I'll be explaining a topic called Statistical Process Control, or SPC. The purpose of using SPC is to maintain or improve characteristics of a process, such as manufacturing efficiency, keeping measurements within a specified tolerance, and reducing catastrophes during a process. SPC can be used in any situation where outputs of a process can be quantified. In SPC, the two major characteristics we strive to improve are stability and consistency. Kind of like how nobody wants the transmission to fall out of their car, proper use of SPC will help with that. When data is collected, control limits and specification limits are applied. Specification limits are chosen for the manufacturer/client's needs, and they define what's an acceptable part. The control limits are a set of tolerances a bit tighter than the specification limits, and they make it easy to spot something in a process that isn't going as planned. So, what we want to look for is trends in our data. Any kind of trends or non-randomness makes a set of data a great candidate for SPC. There should be plenty of data though. Like with all statistical methods, lower sample sizes result in less accurate results. Ideally, no less data than the amount I have here. In this torque at failure chart, there's an obvious dip in the torque ratings starting around sample number 10. This is a serious indication that something went wrong in the manufacturing process. This is also an example of how SPC simplifies the process of locating errors. To keep this short, I won't read this whole example, but the gist is that the car company Dodge was testing their rear wheel hubs and they came across a small sample of parts which had a low torque at failure rating. When the engineers took a closer look at the broken hubs from sample 2, they noticed some air bubbles in the hubs from an error in the manufacturing process. They knew right away to look into sample 2 because that sample's mean fell way below the control limits of the process, and they knew something was wrong. One other thing to point out is how little tolerance there is for the lower control limit when compared to the upper, because it's much safer to trash a part they're not confident in. The upper limit is so much further above the expected value of 2,000 pound-feet because there isn't any harm in the part being stronger than expected. If the parts surpass that upper limit, the engineer should probably look into it to see what they're doing right. In closing, the applications of SPC are endless. You can apply SPC to literally anything, even things like daily chores. Nobody would do that because it's ridiculous, but hopefully this video gave you some insight on the wonderful world of SPC and how it's used.